Hi there, I am Ilghazi Sufyan, Microsoft Certified Data Engineer and Power BI Specialist. In this video, we are going to talk about variables in DAX. Whether you are just starting out or looking to sharpen your skills, this will help you get one step closer to mastering Power BI. Let's get started. Let's start with a simple, basic example of how variables improve readability. Let's start with a simple but practical example, calculating the average sales per customer. So first we declare a variable called sales amount that calculates the total revenue by multiplying quantity by unit price and applying then any discount if there is any. Notice how we use the SumX to iterate through each cell and compute this row by row. Next, we create a second variable, number of customers, which counts the distinct count of customers ID to avoid double counting repeat buyers. Finally, we return the result by dividing total sales by the number of customers. This structure makes the formula self-documenting. And we can either make it more self-readable by declaring the result as a variable result, declaring a result variable, and then we're going to return the result variable. This way is more readable and easy to display. So the key observations here that variables are defined using the var keyword and the return statement specifies the final output. Now let's create a complex measure that shows how variables help in debugging. So I'm going to paste this DAX code, and here we are applying a discount only to customers who spend above average. First, we calculate the average sales using the average X over customers, ensuring we get the true average spend per customer. We then define our discount percentage as a variable, making it easy to adjust later. Here, the real power here is from this result calculation, where we iterate through each cell with SumX. For each cell, we check if the customer's total spend exceeds the average. If they qualify, we apply our 15% discount. Otherwise, we charge a full price. So without variables, this would be unreadable nest of calculates, if as you see. But by breaking it down into logical steps, the business logic has been clear even in a while of period of time. For debugging techniques, we can replace the results here for example for this average sales in order to inspect intermediate values, and the variables are easy, allowing easy inspection of calculation steps, and as we said before, improves the readability of the code. So now we are going to look at variable evaluation when they are getting evaluated, and to do that we are going to work with this code here. So time intelligence calculations, that's calculations that include time, benefits most of the times from variables. Here we are measuring a year-over-year growth. So notice that here we first isolated the current year sales using a sample year filter here, because what we have to put in mind is that variables are constant once evaluated, and variables are evaluated in their specific context. So what I mean by that is that here this current year sales variable we declared, it takes here the value of the sum of sales for only the year of 2025. That's because we applied a filter using the calculate function to only calculate the sales of this year. So the value that this variable takes is going to be constant. That means that if we declare this variable in another context like here, it won't be affected by the filter context of that place. It's going to be treated as a constant. This is where you have to be careful. And the same here for this previous year sales. We are working with the filter of same period last year. That means that we are calculating here the sales for the last year. That means that the value that's stored in here is the sales of the 2024. So when we are referencing these variables in here in the results, if we want to apply another filter, we have to be careful, because that's not going to be applied to the variables in this case like this. So be careful when referencing variables across different filter contexts. We can also work with nested variable declarations. Like for example, in this, okay, I'm going to paste another DAX code in here. So as you see here, I can declare variable promotion discounts, and within this variable, I can declare other variables that have their return statement, and I can even use the same name within this. But for example, base price in here, I can use it in here too, and probably I won't have a problem differentiating between these two declarations. For this example, we first compute the base price, a simple sum of quantity times price. Then we check if we are in a single promotion context which has one value. And in the nested if, we store the current promotion ID in a current promo, then look up its discount percentage. Only if all this succeeds do we apply the discount. Finally, we subtract any discount from the base price. This pattern is powerful because each variable isolates a specific concern. The nested structure matches our business logic flow, so we can easily add more conditions without creating a spaghetti code. Without variables, this would require multiple separate measures and lose all readability. So now let's see the common pitfalls. So remember, as we said, that variables capture values at a definition time. So for example, if we took this DAX code in here, this captures the filter context of this variable. So suppose that we declare that a variable, we create a measure, we created a measure called total sales, for example. So in here, this value that's passed to this total sales is captures the filter context within here. That means that we want, when we want to use it, to use this variable in here, multiplied by this percentage, for example, this is not going to work as expected, because it won't take this filter back for consideration. Why is that? Because this filter context is applied after the declaration of this variable in here that already takes this filter context. That's the idea. So in order to have the correct approach for this, it's better to declare the variable and work with the measure that we have already directly. So within here, this the filter context is taken to the consideration while calculating the total sales, then multiplying it by this percentage that we want. So variables are typically evaluated only once, and this is a powerful thing, because if there is, for example, a part of the code where we reuse it more than a time. So every time we declare, for example, this variable, the Power BI engine has to calculate it over time every time we declare it. So if that's the case, it's better to declare it in a variable, then use the variable, because when you declare it in the variable, it's only computed only once. So now you are optimizing for the engine to not recalculated every time you declare the measure. And so that's it. Reference variable multiple times without a recomputation. As we said, use variables to improve the code readability, and define variables in the most appropriate context, because they are incredibly helping optimizing your code and making it easy to read. The common mistakes to avoid is that confusing between variables and measures, as we specified right now, misunderstanding variable evaluation contexts, and incorrectly referencing variables across different contexts. So, in conclusion, variables in DAX are a powerful tool for improving the code readability, enabling easier debugging, optimizing calculation performance, and creating more maintainable DAX expressions. As a pro tips, when in doubt, use a variable, name variables descriptively, and use nested variables for complex calculations, and always consider the evaluation context. If you found this video helpful, feel free to subscribe, like, and share it with others. And if you are looking for a complete structured course on Power BI from beginner to advanced, I have got a full course available on Udemy. Feel free to join me there and take your Power BI skills to the next level.